So we have an example of equilibrium here, and we've got a beam suspended from perhaps the ceiling by a rope, and we've got a 28 Newton force downward at one point and a 10 Newton force downward at another point. So it's fixed at this point, and we're asked to find the weight force of the beam. So the first thing we should do is label the rest of the forces. So we know there's going to be a support force upwards at this point x, so if I call that F of x, and the weight force of the beam will be operating halfway along the beam, so that's going to be Fw there. And just for putting in the distance, it's going to be the same distance from either end. The whole beam is 5 meters, so it's 5 meters divided by 2 is 2.5 meters away. Okay, so we're trying to find Fw through the whole thing. We don't know Fx. We have to remember that we have the two equations to use for equilibrium. The sum of the forces equals 0, and the sum of the torques equals 0. We could eliminate one of these unknown variables. One unknown variable is the weight force of the support force, and the other is the weight force of the beam, which we're trying to find out. We could eliminate one of those by making a pivot point at point x. That seems like a good way to go about this. So we might do that, but we might come into trouble with that a little bit later on, possibly. No, we should be right. In actual fact, it won't matter. We can draw both equations just because it's a good idea to keep them all there. We're probably not going to use the sum of the force equation, but anyway, sum of the forces equals 0, which equals down as positive, so 28 plus 10 minus Fw plus Fw. Ooh, nearly got it. So it's now minus F of x, and what this is saying is F of x is equal and opposite to the rest of the forces added up. So now a useful equation is the sum of the torques, and we're going to take our pivot point at about point x. So that means the distance from point x is 0, so 0 times F of x means we can eliminate that from our equation. Okay, so let's go right ahead. Clockwise torques first. So clockwise is going to be our positive. That means, and I should just make a note as well, that we made down to be positive for earlier. It's not actually that essential because it should be obvious from your equation to anyone who's marking an exam question, but it's a good idea to put things like that in. So first of all, we've got this distance here, which is going to be 0.5, because remember it's 3 meters for the top bit, 2.5, the difference is 0.5, times by Fw. So I'm going to write it in that order, because I look at the distance first, 0.5 times Fw, putting brackets around it to keep it separate, plus, we've also got the 3 meters times by 10, 3.0 times 10. And then minus, we've only got one torque operating in the opposite direction, and that is at 2 meters times by 28 newtons, 2.0 times 28. Close the brackets there. Okay, let's just cruise on up. If we rewrite our second equation here, just to be a little bit more useful, we will see that we have Fw, in fact, in the whole equation there's only one unknown, Fw, so that's going to give us the solution. Let's rewrite it anyway in a good way. So we've got 0.5 Fw, make that point clearer, plus 30, so it's 3.0 times by 10, that point is not obvious, minus 2.0 times 28, which is 56, minus 56. Okay, so we can rearrange this, or we can just deal with this section here first. So it's going to be 0.5 Fw, we're plus 30 minus 56, so we're actually going to end up being minus 26. Is that right? 30 minus 26, yep, minus 26. So we can rewrite this equation, remember that was 0 equals, so we can rewrite it as 26 equals 0.5 Fw, which means to find Fw, going to be 26 divided by 0.5, which is actually the same as 26 times 2, which equals 52 newtons. Gives us that force there. Okay, so going back up, the weight force of the plank is 52 newtons. And how that works out is, with the principles behind it, that weight force has to be enough operating at that distance to provide enough clockwise torque to balance up the only counterclockwise torque when it's combined, I guess, with that torque applied at the 3 meters. Okay, just out of interest, we can find out what the value of Fx is, if that was part of the question. So we would rearrange this equation here, because we now know that, what was it, 52? Yep, 52, Fw is 52. So there's 52. So 28 plus 10 plus 52 should equal, let's do that, 28 plus 10 plus 52 should equal Fx. And that's just a rough, quick version of rearranging it. That's going to be 38 plus 52, which is 40 plus 50 is 90 newtons. So all of the downs are equal and opposite, balanced by the ups. And there we go, that's how you use the equilibrium equations.